Okay, I wanted to provide you guys some data from the last lab we did, which was over Newton's laws. So first thing I want to do is I want to go ahead and connect to my cart. Okay, so I have a graph set up here. It's going to show me the force and the velocity at the same time. I need to make sure that I zero out the force scale. There we go. So the first reading we're going to have is with 750 grams, 0.75 kilograms. There we go. We hit start. Normally, let's see. And by the way, this is with the 10-gram mass. Okay, so that's for run one. You'll get a copy of this. So now I'm going to go up to the 20-gram mass, and we're going to do the same thing again with this 750 grams. So you'll need to convert that to kilograms for this lab. So we're going to bring this back. So again, now we have a 20-gram mass that's providing a force, and the cart's mass is 750 grams. This is run two. Okay. Now we're going to go with 30 grams for your mass that's on the string. Again, we're keeping the inertia the same. The mass of the cart is staying the same. The only thing we're changing is the force. So this is going to be run three. Okay. Now we're going to switch it to where there's a 40-gram mass providing the weight to the string. Okay. And finally, we're going to provide a 50-gram mass. For weight to the string. Of course, when I talk about the string, when I talk about the 10, 20, 30, 40, and 50, I'm really providing you guys just the mass on the string, which is going to provide a force. And we'll talk more about that in just a moment. Okay, so this is 50 grams for the mass on the string, still 750 grams of mass on the cart. Okay, so that was changing force, but keeping the mass the same. Okay, I just want to remind you guys how to read these graphs. So I'm going to pull this down right here. You guys can see that I can pull down right here, make the graph bigger this way, and pull over. So let's go back to run one. And I'm going to make it a little smaller now. There we go. So right here, this is the velocity versus time graph. The way you know it is because purple is y2. If you look over here, y2 is velocity. The blue is the force being provided. And you got to remember on the front of the force cart is where the hook is for the force cart. And that's where that's where it measures the pulling force. So that's going to be the most accurate force you're going to find. So I would, at this point, ignore the mass on the string. That's really not part of the equation. That's just providing a constant force due to gravity. This is the force you're going to use. The blue force is the force you're going to use for this laboratory. So how do you determine the force? Well, I would take, let's make sure that we're on the blue. So I'm going to choose blue, Y1. I'm going to come down here and I'm going to select the area that it was accelerating down the ramp. And how do I know that's accelerating? Well, if you look at the purple, that's the velocity versus time graph, and the velocity is increasing, so that's where it's going down the ramp. So I'm going to come down here and hit the sum button. You could have done this earlier and hit mean. Okay, that's going to give you the mean of 0.089831 newtons. Now we're going to go ahead and look at the acceleration, because that's the other part that you're really interested in, is the acceleration. Of course, acceleration is the slope of the velocity versus time. So I've selected Y2, which deals with velocity. I'm going to go over here and select this range. Now notice that I can pull this back and forth to change that selection. And if I click on it, click right here, and the slope is 0.123. So that's the only thing I'm going to show you during this. You're going to have to find the rest of the data out. Okay, so let's go on.